So if we have to determine the conductivity of a solution using conductivity cell, the cell constant G star should be determined first. And how is it determined? Using a solution like potassium chloride solution whose conductivity is already known or fixed. So according to equation, the cell constant G star is equal to R kappa. Kappa for KCl solution is known. So by knowing R and kappa, G star, the cell constant, can be calculated. Once the cell constant G star is calculated or determined, the conductivity cell is filled with a solution whose conductivity is to be determined. Now let us see the arrangement used for measuring the resistance of a solution of an electrolyte. It consists of two resistances, R3 and R4, and a variable resistance R1, and the conductivity cell having an unknown resistance R2. The Wheatstone bridge is fed by an oscillator O, that is a source of AC power. P is a suitable detector, and the detector can be a headphone or any other electronic device. When the bridge is balanced, current will not flow through the detector. So under these conditions, when the bridge is balanced, the unknown resistance R2 will be equal to R1 into R4 by R3. So if we have to determine the conductivity of a solution using conductivity cell, the cell constant G star should be determined first. And how is G star determined? Using a solution of potassium chloride, whose conductivity is already known. According to the equation, we have G star is equal to R kappa. Kappa for KCl is known. R is measured. So G star cell constant can be determined. Once the cell constant is determined, the conductivity cell is then filled with a solution whose conductivity is to be determined. Now let us see the arrangement used for measuring the resistance of a solution. It consists of two resistances, R3 and R4, a variable resistance R1, and the conductivity cell having the unknown resistance R2. The Wheatstone bridge is fed by an oscillator O, that is a source of AC power. P is a suitable detector. It can be a headphone or any other electronic device. And when the bridge is balanced, current will not pass through the detector. So when the bridge is balanced, the unknown resistance R2, which is the resistance of the solution taken in the conductivity cell, R2 will be equal to R1 into R4 by R3. Thus, the unknown resistance R2 can be determined. Once the cell constant and the resistance of the solution in the cell is determined, the conductivity of the solution can be calculated using the equation kappa is equal to cell constant by R, or it is equal to G star by R. We know that G star is equal to R kappa. So what will be conductivity kappa is equal to G star by R. What is meant by molar conductivity? Lambda m. Molar conductivity lambda m of a solution at a given concentration is the conductance of volume V of the solution containing 1 mole of the electrolyte. It is kept between two electrodes with area of cross section A and distance of unit length. Lambda m is equal to kappa into A by L. But L is equal to 1 and A is equal to V. Therefore, we get lambda m is equal to kappa into V. If the unit of conductivity kappa is Siemens per centimeter, then molar conductivity lambda m can be calculated using the formula 1000 kappa by C. Then the unit of lambda m will be Siemens centimeter square mole inverse. If conductivity kappa is given in units of Siemens per meter, then molar conductivity lambda m can be calculated using the formula kappa by 1000 C. The unit of lambda m then will be Siemens meter square mole inverse. C is the concentration of the solution in moles per liter.